Hello friends, welcome in lecture of fluid mechanics subject. Myself Mitesh Patel and I am an assistant professor in a mechanical department at a Dr. Subhash Technical Campus, Junagadh. Today's our lecture topic is a Buckingham'S Π Theorem. So in this lecture we discuss about the statement of Π theorems and the application of Π theorems and how the problem is solved through the Π theorems. So let's start the lecture. First of all, Buckingham Π theorems and methods of dimension analysis. With the help of this theorem, we can develop the equation of n number of dependent variables, which can be not possible in a Rayleigh's method of dimension analysis, because if the number of dependent variables is large, then this method is more laborious and difficult. So this problem of Rayleigh's method is overcome into the Buckingham's Π theorem or method. Now, statement of Buckingham's Π method: if there are n variables, dependent or independent, in a dimensionally homogeneous equation, and if these variables contain m fundamental dimensions. Fundamental dimensions means m, l, t. Then the variables are arranged into n minus m dimensionless terms. These dimensionless terms are called Π terms. Okay, and from the Π terms we can find out the arbitrary value of arbitrary powers, and then we have to find out the relational equation. Okay. Now we see the procedure for solving the problem by Buckingham's Π theorem. Let's start the procedure. Okay. The resisting force R of supersonic plane during the flight can be considered as a dependent upon the length of aircraft L, velocity V, air viscosity mu, air density rho, bulk modulus of air K, and express the functional relationship between the variables and resisting force. Okay. Now, solution of this problem with the help of Π theorem. So first of all, the resisting force R depends upon a length of aircraft L, velocity V, viscosity mu, air density rho, bulk modulus K. Hence, R is a function of L, V, mu, rho and K mathematically. So R is equal to function of L, V, mu, rho, K. Okay. So it can also be written as a function 1 of R, resistance force R, length of aircraft L, velocity of air V, mu, viscosity of air mu, density of air rho, and bulk modulus K is equal to 0. Now total number of variables, we have a 6 variables. So n is a number of variables. The value of variables is a 6. And number of fundamental dimensions, we have a m, l, t. So it's a 3. So number of fundamental dimension is denoted by m. So m value is 3. Now we have to decide the number of Π terms that can be defined by the n minus m value. So we know that what is the n and what is the m. N is the number of variable and m is the value of fundamental dimensions, that is a 3. M value is 3 and number of variable we have a 6. So 6 minus 3 is equal to 3. Though we have 3 variables for this, for solve this problem. Okay. We have to take a 3 Π terms to solve this problem. Okay. Now we have to find out the MLT form of all elements or variables. First of all, resistance force. So we know that the unit of force is a Newton. Force, mass into acceleration. So m into meter per second square. This is a mass. So kg into meter per second square. So its MLT is a m l t minus 2. Okay. So m l t minus 2. Now velocity MLT we know that meter per second square. Sorry, meter per second. So L t minus 1. Viscosity unit is a Newton into meter per second square. Okay. Sorry, Newton into second per meter square, unit of viscosity. So we have find out the MLT, m l minus 1 t minus 1. Density, volume, mass per unit volume, so m upon l minus 3, and bulk modulus is a k is equal to dp, change in pressure upon volumetric strain, dv by v. Okay, volumetric strain. So strain having a no unit, so unit of bulk modulus is a pressure, Newton per meter square. Okay, so MLT of bulk modulus is a pressure MLT m l minus 1 t minus 2. Okay, now start the further procedure. Now go for the further procedure. We have decided the pi term. How much pi terms are used for this problem? 3 pi terms, and then this is decided by n minus 1. We have get the value of n minus 1 is a 3. Let's divide the, we have to take a 3 pi term to solve the problem. Now each pi term having a variables. How much variables is there in the pi term? That is defined by the m plus 1. So m is a fundamental dimension value, 3 plus 1 is a 4. So each pi term having a 4 variables. Okay, so now we write the pi 1, pi 2 and pi 3. So we have 3 pi term and each pi term having a 4 variables. So first of all we have to decide repeating variables and then non-repeating variables. So rules of repeating variable is the first repeating variables is take from the geometrical property. So we have a 6 variables in which L is a geometrical property. So L variable is taken as a first repeating variables, and now second repeating variables is taken a flow property of fluid. So we have a 6 variables. In this flow property of fluid is a velocity or acceleration. So here a velocity is taken as a second repeating variables, and third repeating variable is taken from the category of property of fluids. So property of fluids in 6 variable defined by the viscosity and density. So you can take a viscosity or density, any one from 2. So here we can take the density as a repeating variable. So it's the name of repeating variable. It repeats in all 3 pi term as shown in slide. So write the LV and rho, LV and rho, LV and rho in each pi term. Now write the arbitrary power to the repeating variable. Any power you can take. So here A1, B1 and C1, A2, B2 and C2, A3, B3 and CT. Okay. Now we have to put the non-repeating variable in each pi term. So remaining variable is taken as a non-repeating variable. So each pi term having a any one non-repeating variable. So 3 non-repeating variables are left: resisting force, viscosity mu, and bulk modulus. So any pi term taken in any of 3 of 1. Okay. So ગમે તે પણ લઈ શકો, mu છે એ તમે pi 1 term માં પણ લઈ શકો, r છે pi 2 માં પણ આવી શકે, એનાથી કંઈ ફરક પડશે નહીં. So not any change in a value or any equation if the any non-repeating variable are considered into the any pi term. Okay. Now we have to start the further procedure. Now we have to comparing the MLTs. So first of all, we take the first pi term and write a pi term into the MLT forms of all variables. Okay. So pi term is a dimensionless number, so it's not having MLT. So it's M, L and T is a 0. Now L, now in right side of pi 1 term, L, V, rho and R. So put the MLTs of all these variables. L's MLT is a L, velocity MLT, LT minus 1, and density MLTs we find out in first, MLT minus 1, and resisting force, look at MLT minus 2. Now write also the arbitrary power respectively of each variables as mentioned in slide. Okay. Now we have to compare the MLT power left side and right side of the equation. Okay. So first power of M is compare left side and right side. We know that the left side having a no MLTs, so power of M is a 0 to left side. Right side we having a M power is a C1 plus 1. Okay. Now we comparing the power of L. So left side power of L is a 0 and right side A1, B1 minus 3C1 and 1. Okay. Now we comparing the power of T at left and right side. Left side 0 equal to minus B and minus 2. Okay. Now C1 is equal to minus 1 and B1 is equal to minus 2. So put the value of C1 and B1, so we get the value of A1 minus 2. Now we have all value of powers A1, B1 and C1. So put the value of powers in this equation of pi 1 term. Okay. So according to power we arrange the all variables. So R upon L square V square upon rho. Okay. Here L having a power A1. So A1 value is a minus 2. So L having a power minus 2. V having a power B1. So B1 value is minus 2. So we have a power minus 2. Rho having a power C1. So C1 value is minus 1. So rho having a minus 1 power. So now arrange the equation according to power. So pi 1 is equal to R upon L square V square into rho. Okay. Now we same procedure follow for the second pi term, pi 2 term. The all variables of pi 2 term write into the form of MLTs and compare the power of M, L and T's and find the value of arbitrary power. So here we have find the value of arbitrary power. C2 is equal to minus 1, B2 is equal to minus 1 and A2 value is also minus 1. So put the value of power in pi 2 term. So we get we arrange the variable according to power mu upon LV rho. So pi 2 is equal to mu upon LV rho. Similarly, third pi term procedure is follow into the third pi term. All variables of third pi term write in form of MLTs first, and then compare the power of M, L and T and find the value of arbitrary power A3, B3 and C3. Okay. A3 value is 0, B3 value is minus 2 and C3 value is minus 1. So here L power is 0, V power is B3, so minus 2 and rho power is C3. C3 is a minus 1, so rho power is minus 1. So here pi 3 term having a k upon v square into rho. Now substituting the value of pi 1, pi 2 and pi 3 in equation 3. And equation 3 is this equation. So in this equation, function of pi 1, pi 2 and pi 3, put the value of pi 1, pi 2 and pi 3 equal to 0. Now rearrange the equation. The resistance force depend on the other variables. So resistance is a main in this equation. So write in this way the equation. This pi term is equal, move to one side of equal, and other pi terms is right into the other side of equal, and 5 is a constant. Now we write as a relational equation in this manner, and this is the final relational equation developed by the Phi theorem for a resistance force to given dependent variables. Okay. Now we take another example, so you can get easily how the example is solved through the Phi theorem. So here efficiency of Fn depends on the density rho, dynamic viscosity mu of fluid, angular viscosity omega, diameter d of the rotor and discharge q. Express the efficiency in terms of dimensionless parameters. Okay. So we have to find the relational equation for the efficiency. So first of all, write the equation into the manner. Efficiency is a function of given dependent variables, density, mu, angular velocity, diameter and discharge. Okay. And we also can write in this form or in this form. Either in this form or either in this form. Okay. We have a variables, number of variables is a 6 and fundamental dimension have a value of 3, m, l and t. So 3. So we required pi term is a n minus m. So we have to write a 3 pi term to solve this problem. Now we find all MLTs of all variables. So density we know that MLT minus 1, kinematic viscosity MLT, ML minus 1, T minus 1. The unit is a Newton into second per meter square. Angular velocity is a radian per second. So radian is not count in a fundamental dimension, only second is count. So angular velocity MLT is only count a second. So T minus 1 for angular velocity. So note this MLT of angular velocity. Now diameter MLT is L. Discharge volume per unit time L cube T minus 1. Okay. Now we write the pi 1, pi 2, pi 3 and each pi term having a variables m plus 1. So each pi term having a 4 variables. So m value is 3 plus 1. So 4. So each pi term having a 4 variables. So first we find out the repeating variables. First repeating variables is taken from the category of geometrical property. So geometrical is property defined by the diameter. So first repeating variable is a diameter. Second repeating variable is select from the category of fluid flow property. The flow property is defined by the velocity. So here angular velocity is a second repeating variable, and third repeating variable is considered from the category of fluid property. So fluid property is defined by the viscosity, density. So here we consider we have select the density as a third repeating variable. Okay, and now fourth repeating variable is any left variable we have taken for in any one pi term. So here is a efficiency, here is a viscosity, kinematic, and discharge Q. Okay. Now first take the first pi term and write the pi term in form of penalties, which we have find in start. Now find the value of arbitrary power through comparing the power left and right side of MLTs. Okay. First comparing the value of M, right side and left side. Pi term is a dimensionless number, so it's not having MLTs. So all power of M, L and T at the left side is a 0. Okay. Now comparing the power of M. So left side is 0, right side M power is a C1 plus 0 less C1 plus 0. Okay. Now power of L is compared left side and right side. Left side 0, right side A1 plus minus 3C1 and 0. Okay. Now power of T comparing by minus B1 and 0. Okay. So all value of MLTs are 0. Okay. Or MLTs values are 0. So the power of our values are 0. So equation is efficiency is equal to efficiency. So note that here we know that if the variable is dimensionless, the efficiency is a dimensionless term in a non-repeating variable, then we not have to require to solve this or find the value of arbitrary power. If the variable is dimensionless, itself is a pi term. Here the variable efficiency is dimensionless, and hence efficiency is a pi term as it exists in the first pi term, and hence pi1 is equal to efficiency. Then there is no need to equating the powers, and directly value can be obtained. So we don't have a required to follow the procedure. We can write the pi is equal to efficiency if the non-repeating variable is dimensionless. So efficiency is dimensionless. We directly write pi1 is equal to efficiency. Okay. We don't have to follow the procedure. We directly write it. Now solve the second pi term. Write the all variables in form of penalties. Okay. Now comparing the power of M, L and T, left and right side, both side, and put the value of A2, B2, C2 in this pi term. So D having A2 power, so A2 value is a minus 2, so D have a power minus 2. Omega have a B2 power, so B2 value is a minus 1, so omega having a minus 1. Density having a power C2, So C2 value is -1. So rho having a power -1 and mu is a power line. Now according to power, rearrange all variables. So pi 2 is equal to mu upon d square into omega into rho. Okay. Now similarly for pi 3 term, write the pi 3 term variables into MLT form and comparing the MLT at left side and right side and find the value of arbitrary power A3, B3 and C3 and value of A3, B3, C3 write in a pi 3 term equation and according to power rearrange the variable q upon d square into omega. So pi 3 is equal to q upon d square w. So all three pi terms we have find out. So first equation is a function of pi 1, pi 2 and pi 3 is equal to 0. So here they put the value of pi 1, pi 2 and pi 3. So function of efficiency mu upon d square omega rho comma q upon d square omega is equal to 0. Now we have to find out the equation for a efficiency or expression for efficiency. So efficiency is the other side of equal and other side of equal and the other variables or other pi terms are in other side of equal and constant is defined 5. Okay, and this is the relational equation. Okay, I hope you are very well understand what is the statement of Buckingham's Π theorem and how the problem is solved through the Buckingham Π theorem. Okay, thank you friends.